And so the key agenda of the webinar today is going to be, just a second here. Yeah, so the key agenda for the webinar today is going to be on giving you all a quick overview about blockchain and its characteristics. So I'll try, my maximum not to spend on very, very basic concepts, but rather than I will talk about a certain, say misconceptions on blockchain and what is it that it's truly about, so that sets a lot of context. And then the second part of it is, I'll try to cover 2 or 3 main use cases where blockchain is a perfect fit. And I will also give you a good overview about how do you understand the fitment of a blockchain use case. And the next stage of the webinar, I will probably explain more on blockchain implementation and what is the complexity versus the ease of implementation of a blockchain solution. And so again, I'm sure most of you would be thinking, what is it that you'll get to learn? Of course, the first thing is, how do you assess the right use case of blockchain? Because there's a lot of use cases that come up, and then we are not yet sure about, if this is the right fitment for a blockchain, technology for me to provide there. So that is a big gap that is currently seen. So how do you go ahead and address it? And the second one is, why did blockchain succeed in a few industries? And so that is something that we can go ahead and explore. And the third, of course, as I had already said, the challenges and complexity, and what exactly should you, what kind of solutions can you probably look at when you look at ease of implementation is something that you will learn out of this webinar.
Yeah. So thanks, Aditya. So I at the end of this webinar, we will also share you a couple of use cases and how we have used that use cases, and see we have used an assessment framework and make sure we have seen like how this use case fits with this assessment framework and whether it suits blockchain. Blockchain is needed for this use case or not. So we are covering with 3 unique use cases, 2 on fintech and 1 on healthcare. So hope this will be very useful for you, and we'll be open to any questions. So again, I'm repeating. So if you could post your questions in the chat window, last 15 minutes will be your Q&A session. Yeah.
Again, talking about the speakers, so I am Aditya. So I'm a certified blockchain expert, and I also handle data and big data engineering with TVS Next. And Jagan is our Chief Technology Officer at TVS Next. And he comes across with more than a decade experience in providing digital solutions, and also providing, and also he comes across with a very deep understanding of a lot of enterprise related projects and its technologies. So that is about the speaker list for today's webinar. And proceeding to which, so blockchain again, there is, before I probably explain, I just wanted to touch upon a few misconceptions, right? So the first one being, the question that's been primarily asked in most of the social media forums and all that is, how is blockchain any different from say an ICO or any cryptocurrency? So in that particular thing, blockchain is actually, is a technology that is underlying any of these crypto tokens and cryptocurrency, but it is not exactly, the cryptocurrency itself, right? So blockchain is a very generic technology that can be used across multiple use cases. And when you primarily look at the key characteristics of a particular blockchain, it provides us with a distributed ledger, right? A ledger that is not just concentrated on a centralized system, but it is something that is distributed across the ecosystem of a blockchain solution. And the digital records is the main characteristics, because what we currently have in most of these IT applications currently is all pseudo digital records, because it's also present as a manual record, and no one has no one is pretty much 100% sure if the entire record is digital. And the third one is updated near real time. The reason why we call it near real time, of course, we're going to cover it in much more detail, but the reason being there is a certain level of agreement or consensus that happens between different ecosystem parties before the data typically gets inserted into the ledger. And chronological and timestamped, because it all follows a certain order and it is all timestamped before it gets into the ledger. Cryptographically sealed is something which is one of the most important features of a blockchain, because it just does not offer distribution, but it also offers encryption, because it also encrypts a particular data and then stores it in the ledger, and it gets encrypted in an asynchronous way, which we can also discuss it in a later state. And irreversible and auditable, because any particular change in the particular ledger is something that gets updated as a transaction by itself. And interoperability, because it provides a lot of transparency in the ecosystem, because everyone holds their own ledger, and any change typically gets we can pretty much find out in no time. And the consensus or the agreement algorithms that run behind a particular blockchain can typically identify a particular node or particular party having a certain amount of data that is not in sync with any other data and can probably reject it itself. So that is how it works. And fewer third parties is a main characteristic. That is where most of these use cases are getting revolved upon, so which we will be touching upon in the following slides. Okay. And
so Aditya, before going in detail about this blockchain technology stack, so I have a question for you, right? The common myth is we need to rewrite the entire application layer, or do I need to completely redo my IT investments, right? Or my new the whole application development I need to rewrite. So is that correct, Aditya?
So Jagan, I think spot on. So that is exactly what I was about to discuss on. And so the answer would be no, Jagan, because blockchain typically, again, it completely depends on this kind of use case, but blockchain necessarily does not demand that you rebuild the entire IT landscape. But as blockchain, something that we do typically is we introduce two main layers to the existing IT landscape. So the two main layers are service layer and a network and protocol layer. So that is something that you see here on the screen. And so what is it that we do on a network and protocol layer? And I'll probably get into that detail and then step into the service layer. So that there's a very clear understanding there. So when we speak about a network and protocol layer, so most of the blockchain systems use a protocol which is called IPFS, which is Interplanetary File System, which is a distributed protocol. And when you look at most of these blockchain systems, they are mainly categorized into two main parts, right? So it's either a permissionless blockchain system or a permissioned blockchain system. And when you look at permissionless blockchain systems, there are multiple systems currently available, right? Like Ethereum, Bitcoin, and all these are permissionless blockchain systems. So no one actually controls, or no one actually, there's no regulatory body that is actually present over there which controls the entire ecosystem. So the entire ecosystem is typically, all the transactions are typically inserted by the means of, there are a lot of miners who contribute to the ecosystem and ensure that the data is inserted into the ledger. So that's how it works on a permission. But when you look at a permissioned blockchain system, there are a few contracts that are written, right? So if a certain transaction meets X, Y, Z variables, then it can be inserted into a ledger. And in the ecosystem, there are a few main parties which agree to a certain transaction and it gets inserted. So that's how it works. And typically when you look at the kind of consensus mechanisms. So consensus mechanisms are kind of the key element when it comes to a blockchain preparation, and that is one of the main things that we try inserting into a blockchain solution. And so it can be, the consensus mechanisms are usually very, very huge. There are multiple consensus mechanisms subject to a lot of use cases, because every use case might demand a completely different consensus mechanism. Say, let us take Byzantine fault tolerance, which is something that has been very widely used by common platforms such as Fabric. And Fabric uses something called a little customized version of Byzantine fault tolerance, which is called practical Byzantine fault tolerance, which typically allows us to customize the way in which every transaction can be approved. And proof of stake and proof of work, again, are typically different consensus mechanism, but more to do with permissionless blockchain network. So if you see, Bitcoin and Ethereum, they kind of use proof of stake and proof of work. And so this typically is the network and protocol layer, which is kind of the heart of a blockchain system. And coming to the service layer, so service layer typically dictates about how am I going to connect with the application layer, and what kind of APIs that speak with the network and protocol layer, and then communicates back or pushes the data into an infrastructure layer. So typically, if you can imagine the blockchain itself as a database and distributed across the infrastructure layer, and the kind of data that needs to transact in and out of an infrastructure layer, and then push the response gets pushed back into an application layer, right? And when you look at service layer, typically there are multiple service elements. So it can be a digital identity, it can be a connector. So when you speak about connectors, it can be, say, just imagine an IoT data coming into play, where there are multiple data flowing in, and every data is getting converted as an asset into a particular blockchain, and then those assets are pretty much defined as a means of smart contracts, and these digital assets are consumed by the blockchain and stored in the ledger, right? So there are multiple things, and as a service layer. So again, wallets, if you see, it's just an application over here. It's a service that you can probably create. So any of the ICO and all that itself, all the coins itself are an asset which can be defined, when you develop, and then those assets are then validated with a certain consensus, and then the data is typically flowing in and out of infrastructure layer. So that is about the technology stack. I hope I was also able to answer your question, Jagan, because you need not completely reinstate your IT infrastructure, but rather you introduce two main layers which then speak to a blockchain, which help us implement a blockchain solution.
Yeah, that really helps, Aditya. Thank you.
And moving on, so now the key problem that most of us have is there are multiple ideas that come into play, but we really have trouble in identifying the kind of use cases that I really need to look at, right, for a blockchain implementation. So typically, when you look at this particular slide, what we've done is we put across a few questions that we need to ask ourselves, and before we begin looking at a blockchain solution. So these questions typically is about documentation. So is the documentation paper based, right? So currently, how is it that you're collecting all the records, and how is it that you're storing? And then are there large amount of records that are needed? So now, if the answer for this is yes, and then the next question should be, are there multiple participants, transmitting data from one party to another? And should there be any transparency between different parties? And again, sometimes in most of the cases, the transparency is not very much needed between different parties. But when we look at a scenario such as supply chain for a company, the transparency sometimes is completely needed, because when we look at a large, when you look at a large manufacturing firm, there might be a lot of vendors, there might be a lot of suppliers. So in that case, there's a lot of trouble that the manufacturing firm takes in order to answer each of the queries, right? So as the PO been received, as the invoice has been generated and all that. So there's multiple queries that come in which are pretty much redundant, right? So in that case, transparency between all these parties in that ecosystem, which are interrelated to one another, if it can all be brought into one ecosystem, there's a lot of problems that could be solved because of how fluent that the data can probably flow, and everyone holds the same record, so they all know what they're talking about. It's not that the vendor has some other data and the enterprise has got some other data, right? And time sensitivity. So will the transactions benefit from being real time or synchronous? So that is a very important question. So this question can actually be put into two different areas, right? So there are areas where the real-time data becomes an extremely big key. So do you have use cases revolving around real-time data? So in most of the cases where you can see real-time, if you wanna, at a real-time basis, feed into the ledger and then feed out of ledger and understand what is there. So in that case, blockchain may or may not be a right use case, but when you look at time sensitivity in a different area where you try to reduce the time period of a particular transaction, say for example, if you're looking at a lot of third parties in between and they eat up a lot of time, and that is something that you're trying to reduce, might be a very good fit for a blockchain. So again, intermediary, when it comes to intermediary, of course, are there high fees, and then so are there heavy latency, and then does it directly affect your customer experience, and all that are the questions that you can probably ask. And trust, of course, so are there high risk of fraudulent transactions? So this typically is a main point where the fintech kind of tried adopting a blockchain. So that was one of the main reasons, and that was one of the main reasons why healthcare also tried adopting blockchain. So that is something that we'll be seeing in the forthcoming slides. And manual processing again. So is there very high manual operations, and of course, is the cost of reconciliation very high? So if it is very high, so you need to look at a better solution there. So these are the broad questions that you can probably ask. And I will probably take you through a couple of use cases where the validity of this particular framework is something that we can put to test, and we can probably take you through the use cases and then fill it up for you so that we can understand it better from there. And so talking about this particular use case, so first trying to assess about what exactly is banking, all the banks trying to achieve, and why exactly are they going for blockchain, right? So, so when we are going through one of the primary research done by Statista, it says when you look at when they ask them, what are the key areas where the banks are trying to invest on, to most of the CIOs and CTOs, and the answer typically was around mobile payments, which is 43%, and then online and mobile account opening, which is 38.7%, risk management, fraud management, and document management. So when you look at the kind of trend, the trend was more to do with improving the customer experience, at the same time improving security and reducing the risk that is associated with going online, right, and improving customer experience. So these were the two main areas where most of the the CTOs were lingering around and trying to figure out a way, and that is an exact place where blockchain had the right fitment. So that was one of the main reasons why the blockchain was of a great interest to most of the fintech players. And one such use case where we can talk about vendor financing, where I'll quickly explain the access process and what could be done using blockchain. So just imagine in a typical vendor financing kind of a place where there's a client and there's a vendor, and so the client here orders a supply of goods, and then the vendor typically supplies the goods, right? But the intermediary payment currently, just imagine if it's a very high transaction that is happening between the client and a vendor, and the bank typically takes in it takes in the approved invoice, and then post taking in the approved invoice, it typically sends it to the admin, where the admin validates the transaction, admin confirms if it's the right transaction, and then it authorizes the bank's payment department to push the payment to the vendor. And typically the bank's payment department might take some more time in order to push the payment to the vendor, right? Uh, so these are all natural time that is taken just to ensure that a single transaction is done properly. Uh, but when you look at a particular blockchain system, so the blockchain over here not just tries to reduce the time, but it also tries to reduce the the validity of the certain transaction. Say over here, let me go back to the access process, bank's admin department, right? So currently there is a human over there who has to approve a certain transaction. So he may or may not be right in his in his way of approving a certain transactions. Though there are multiple SOPs which demand a particular person to follow XYZ document before he has to approve, but there is no proper contract that is there in place which can probably authorize, probably say he's 100% right, correct? So in a 2D process, in a blockchain, what happens is, say if a client actually sends an approved invoice, so now there is a API request. So just imagine, we spoke about the technology stack, right? So just imagine this particular API request is coming in from the client, from the application, from the client application side, and it is now entering into the services layer. And so now we've got multiple nodes that are currently there. So now what is happening is there is a smart contract that is written, right? So whenever there is a request that is coming in from the client node, so all the nodes define a particular participant in the ecosystem. And now the client node has actually inserted a transaction crypto key into a particular ledger, because now you know that there is a transaction that is coming from the client requesting for a transfer of payment, right? Now the certificate authority node, just imagine the smart contract that is written typically is a particular machine learning model itself. So the machine learning model has got multiple variables, and it typically analyzes on the basis of different variables the probability of this being a fraudulent transaction. So certificate authority node understands the ML model, and then it tries to give okay, go ahead, or no, you'll have to reject a particular transaction. So that particular commitment comes in from the certificate authority node. Now, post the commitment, it again goes back into the transaction crypto key, and then the transaction is recorded. And the bank's payment node, the minute it's okay, the bank's payment node releases the transaction, and of course, the payment gets credited to the vendor. So when you look at the entire process, though there are multiple steps here, so almost all the steps are completely automated. And the time taken can actually completely depend on, if they want to do it completely automated, they can get it done. Or even if they want a certain manual processes in between, it can still be done. But the advantages of this is, what is happening with the transaction, you can real-time track it, and at the same time you get an audit log that cannot be tampered with at all. So you can know who did what analysis in no time at all with the use of a blockchain solution. So that is one of the key benefits of using this. And now let us go ahead and try placing it on the fitment framework, right? Say intermediary, when you look at this particular use case, yes, there are intermediaries, and they do eat up a lot of time, and there's a lot of cost in putting up intermediary. Cost, in the sense, the objective of this is not to actually reduce the cost. I mean, it's not that we want to reduce the cost, but it is something that is more focused on how do you bring in efficiencies into the system. So intermediary, how efficient are they? So I would say, they are not very efficient because of the kind of output or value add that comes out of them. And transparency, there needs to be a lot of transparency across the ecosystem, because everyone's dependent on some way or the other, because only when the payment goes to the vendor probably supplies the goods to the client, right? So transparency is pretty much needed, and it's a mutually agreed process. So transparency is it's a very important one. And information storage, uh, the information currently, when you look at this information, so there are a lot of key, very important information. So the bank's transaction related information is sometimes can belong to the client, and the vendor should also have the same information, because there should not be a misinterpretation of what is the data that each and everyone has. So it's very important. And manual processing, so currently there is a lot of manual processing, and the cost of reconciliation is very high. So definitely that is an yes. And trust. So there needs to be trust and documentation. It has to be brought in, and it has to be digital. And time sensitivity is very high, because someone's business transaction is pretty much dependent on the payment transfer. So when you look at all these things, and when we pretty much mark it as yes, it happens to be a good fitment where we can probably look at a blockchain use case. And having said this, just imagine another use case, which is kind of, a very, very important one, in
So
current scenario,
Aditya,
because,
Aditya, I would like to take a pause here.
yes,
Hope like we all had listened to the first use case, and if you have any questions, please feel free to post your questions, because we have a dedicated 15 minutes of Q&A session. So please feel free to post your questions in the chat window. We'll be happy to answer that. And yeah, Aditya, please go ahead.
Sure, Jagan. And syndicated loans is yet another very, very interesting use case, because most of, of course, we definitely seen a lot of use cases in India as well, where the major airlines, they try taking funding from different banks, and banks typically go to the syndicate, arrange for the financial transactions, and then pull in the money, and then bring it back to the corporation, right? So the problem is, all the syndicate typically depend on the lead arranger bank, because the lead arranger bank is typically a very huge bank, which kind of does a lot of, the background checks, and the probability of, fraudulent, or the risk assessment, and everything is done by the lead arranger bank. And the syndicate typically does their own task, but also depends a lot on lead arranger bank for most of these things. But just imagine, the life with a blockchain. And of course, we can definitely debate as to if this is the right use case, because I'm not, give a disclaimer, I'm not here endorsing the blockchain as a technology. But these are the use cases which really struck a lot with me. So that is one of the reasons why we are sharing it on this webinar. And when you look at a blockchain use case here, so just imagine if there is a certain ecosystem that all these parties agree to be on. So they all know, hey, see, this is the ecosystem that we're going to be on. So these are the rules that we're going to agree to. It's a common rule. And so typically any model or any smart contract that we're going to write will speak these rules, right? So these rules can probably say, hey, see, if X, Y, Z variables are met, the risk assessment is fairly low. So then it is something that we can probably look at investing. So if that is the first step of writing a smart contract, then when a corporation is investing or requesting for a loan, then it passes through a certain smart contract, and the smart contract typically gives a very transparent picture of the risk assessment that is involved over here. And if a lead arranger bank is doing a background check, right, and they collect a few variables, and that again is a very transparent variable that gets recorded, and gets pushed into the ledger. So everyone, the entire syndicate will be able to see those variables, and the entire syndicate will not go through this entire process again and have background check, because if they believe the background check that they've already done is pretty transparent and that is already done, so the entire ecosystem can probably adopt to the same background check. And of course, if they want, they can also do it and publish their results. And this in turn, can automatically, if certain rules are met, automatically the payment can be pushed across to the corporation. So that is how syndicated loans, we can really look at how blockchain can help. So it can help on KYC, it can help on reduce settlement periods, and then every document that is getting recorded is completely mutable. And in a similar way, we also try to fit in to the assessment framework again, and where we see on the basis of factors on how the syndicated loan fits. And when you see intermediary, they eat in a lot of time and efficiency. Transparency is definitely needed, because every particular party in this ecosystem is running on very high risk, be it the corporation, be it the syndicate, be it the lead arranger bank. So everyone's on high risk. So it's a very, very, very important use case on how transparency plays a very important role. And information storage, everyone definitely needs to have the same data. So they cannot have, multiple parties cannot have their own data. So that definitely does not add any value. And manual processing, definitely, if there is any mistake or if there's something that goes wrong, the cost of reconciliation is very, very high. And trust. So everyone needs to have a trust in this ecosystem. And documentation. Most of the documentations currently is paper based, because there's a lot of bills, items of purchase, and all that, which definitely needs to become digitized. And time sensitivity is a major key, because again, as someone's business process or someone's request is greatly dependent on the kind of latency that is there in the current ecosystem. So that also needs to be avoided. So long story short, the places where there are multiple multiple parties in the ecosystem, or when there's a lot of inefficiencies because of third parties, when there's a lot of time sensitivity issues, those are the use cases where blockchain is a very good fit, because those are the areas where we can bring in efficiencies using blockchain. And automating, but how much can we automate is definitely dependent on the efficiencies to write a particular smart contract in the perfect way, where we can go ahead and define it. And on the other side, having said about smart contracts, we also have to pay equal attention and effort in ensuring that we choose the right platform, and we chose the right consensus for a particular platform for us to take forward, because that defines the kind of security that can probably feed into the system. So this is about the use case. And the next one that we will be assessing is a healthcare use case. And so with respect to healthcare, the reason why we had chosen banking and healthcare is typically because we see a lot of similarity when it comes to as far as the industry is concerned, because when you look at fintech and also healthcare, something that is very similar is the transaction standards that they demand out of us, and the data security that is required. But the only challenge in healthcare is the adoption, because in fintech, typically, the data typically some way or the other gets into the system. But in healthcare, that has always been a challenge with respect to adoption from doctors. The way in which the data is actually fed into the system. So those are the areas, but I'm not very sure how far, because blockchain has got very less effect when it comes to adoption. But that is one area which is definitely a trend on healthcare as well. So that is something that we also wanted to point out. And when we look at the use case, so something that we wanted to do is we wanted to actually split it into 4 main areas where the healthcare ecosystem can probably look at blockchain. The first one is again, it's about how a particular blockchain system can integrate with your existing ecosystem, right? And how can you absorb the data and all that. So this is where the services layer kind of comes into play, where the way in which where you can connect directly as a client transaction from via REST APIs to your existing ecosystem, where any client transaction that comes in can be uniquely identified, and it can be digitally encrypted and then processed through a smart contract, and then pushed into a blockchain network. So now, so what benefit do you have when you push it into the blockchain network over here in healthcare? It's typically a very interesting case where just imagine if India is a country and all of the entire ecosystem is currently in one blockchain network. So currently, the government of India has got a lot of open data platforms currently, where they ask, or they even encourage a lot of young students and to just play around with the data and understand or build models and provide us with key insights, right? So just imagine if in a blockchain, if almost everyone's data is there. And it's not that I'm going to view the data, but it's if there is a public data that I can generate, that is a summary of all the transactions, and not the actual transactional data by itself. If I can generate all the public data, right? So just imagine if so the government wants to know how many diabetic patients who are present in Delhi, who are more than 40-45 years of age. So in that case, in no time, in a jiffy, the government can probably get all those data, right? So because all that, every transaction data gets into the system, and only the summary gets visible to the government or any other regulatory body. But the beauty of it is the patients can still hold their own data. So the patient's data still stays with the patient and not with anyone else, and it's still encrypted and stored on their own name. So these are the key areas, how healthcare can probably evolve, and how healthcare can probably use blockchain ecosystem. But there are a few countries who have already started, who have already implemented this ecosystem, and there are very interesting cases that IBM is releasing with respect to what Fabric can do, and so this is something that most of them have already adopted, and this is something that we are also looking at. We are also exploring a lot of use cases on this in TVS Next. And so now, we've spoken a lot on what can be done and why did it succeed and all that. And so when we look at what kind of blockchain solution should I really be looking at, right? So there are multiple blockchain frameworks currently available, and I've got this question a lot, where most of the clients come up to us and ask us, say, this is the use case. You told me this use case is valid, but what is it that, what kind of framework should I go? Should I go for an Ethereum? Should I go for a Hyperledger Fabric, or should I go for something else? So, and what does Azure have? What does AWS have, and all that? So when you look at that, so we decided to actually map it into complexity and ease of implementation. And I think that will pretty much explain it all. So when you look at ease of implementation, right? So suppose, I'm not saying ease of implementation is very high, so you pick it up. So, but what I'm trying to say is, say for example, let us take the Azure blockchain as a platform service, right? So in that case, it uses Hyperledger Fabric, right? So Hyperledger Fabric runs on a PBFT consensus. And when you explore PBFT and when you try to map your entire use cases into a particular consensus model, and you feel, hey, see, this is something that I'm exactly looking at doing, right? So then picking up a backend as a service, or blockchain as a service platform, is the right fit, because there is a solution that is scalable, that is readily available. So of course, and the complexity is very low, so you can definitely go ahead and pick it up, right? But on the other hand, when you're looking at upgrading, or when you're looking at providing or using your own permission ledger and not depending on someone's blockchain framework, but rather you want to do it on your own and you're looking at a very permissioned system. So in that case, the ease of implementation could be fairly lesser because of typical scalability kind of an issue, but which is definitely getting addressed in a lot of the frameworks that are coming in. So when you look at IOTA is able to handle a lot of transactions, vis-a-vis what Bitcoin and Ethereum could ever do. So we are getting into that, and even Hyperledger Fabric 1.0 is able to handle a lot of transactions, and it is also a permission ledger. So that typically slightly reduces the complexity. And when you look at a non-permission ledger, the complexity is the complexity is the same, but the ease of implementation is very low because of a lot of problems such as security related issues that arise because of going public with the blockchain network. So that is one very important pain point to look at. And again, creating your own infrastructure and custom consensus can be a huge this thing. But having spoken about custom consensus with very less ease of implementation and high complexity is typically because of understanding your business use case and trying to customize a consensus and trying to meet your demand and writing the algorithm is a challenge. But having said that, there are multiple projects that Hyperledger is currently launching, because Hyperledger is not just Fabric. Hyperledger has got various frameworks within it, various projects within it. So even in the recent times, I was reading about Hyperledger Umbrella, which is nothing but an revisited version of R3 Corda. So R3 Corda was something that was used a lot by most of the financial institutes. Typically because of a lot of reasons on its on the scalability front, on the consensus front, and all that. So R3 Coda is something that is getting revisited as Hyperledger Umbrella. So that is also receiving a lot of attention from a lot of fintech players. So where it uses a combination of it is not exactly proof of stake, and it is not exactly a Byzantine fault tolerance. So it is a very custom-made model to meet the demands of a lot of financial institutes. So it is a very good tool. I'm very sure it's going to be a very good tool for most of the financial institutes looking at blockchain implementation. So this is about the complexity versus ease of implementation. But what kind of indicative roadmap that you can probably have? So first, we would suggest that you identify the business use case. Ask yourself those questions, and then again, you'll also have to look at your industry, because what is the industry standard and regulatory assessment? Because you will also have to ensure that the regulatory body is also there in the ecosystem. And blockchain stack. So then you can probably look at how are you going to design the solution? What is the blockchain stack, and what are the rules and permission? Where are the location of the nodes going to be? Is it going to be a hybrid system, or is it going to be all on cloud? So that is something that you'll have to design. And post that, you can probably begin with a small proof of concept where you can run it with a few pilot test group, and then you can also finish off your sandbox testing there. And finally is the solution where you look at partner networks and you look at the final deployment and launch. So this is just an indicative roadmap as to what are the processes that you can probably follow before you freeze on the final deployment. And yes, so I think we will go ahead with the questions. So Sid, okay, so if you have any questions, you can probably write it down, and I would be glad to take it up. So you can click on the Q&A and probably put across your questions.
Yeah, I think we haven't received any questions, Aditya.
Okay.
So Aditya, like, can you tell us, like, if anyone of your customer or potential persons who has an use case, if they come and ask to develop a proof of concept, what kind of framework do you have? Do you have a rapid blockchain platform with you?
Okay.
Which you
So
can, yeah.
okay. So Jagan, so we have actually gone ahead and developed a framework over and above Hyperledger Fabric. The way in which it can help us out is, number one, when someone's asking us for a proof of concept, we typically go through the entire indicative roadmap that I had shown earlier. So typically identifying the business use case, and we try to identify how it fits into a particular use case. And we also try identifying the right consensus for them. And post that, we have developed a framework where I can automatically generate all the assets, right? So when we speak about most of the key data, we call it an asset. And the way in which these assets needs to be deployed and developed is a lot of it takes in a lot of time, right? So we've developed a framework where it's a developer friendly framework where you just have to trigger a particular transaction and the assets get generated on their own and it gets stored in the ledger. So that if you ask me, is it something that is more like a platform? I would say it is not a platform, but rather it is something that we internally to accelerate the development time and in turn provide the client a quicker time to market and much more lesser efforts when they're looking at doing a POC.
Yeah. So I think that really makes sense. I think by this we will conclude this session. So thanks, gentlemen, for joining us in this blockchain webinar, and please do drop us email. Like, if you have any questions, or if you want to have a private session also, like we would like to have. And so thank you very much for joining the session.
Yeah, and if you have any questions, you can always reach out to us, or you can also reach out at our generic ID, which is hello@tvsnext.io. Please drop in your queries, and we'd be more than happy to answer them. And should you be having any concerns, you can also reach out to me and Dagan. So you will also be able to find. We will also be sending this content to you as an email where our email addresses will be mentioned, and you can always reach out to us. Thank you so much.
Thank you.